Hi friends, let's see combination of resistances. We know that the current through a conductor depends upon its resistance and the potential difference across its ends. Ohm's law gives us the relationship between the current and the potential difference. The current I flowing through the conductor is directly proportional to the potential difference across its ends. That is, I is proportional to V. Therefore, V is equal to R into I. R is the resistance. In various electrical gadgets, resistors are used in various combinations. There are two methods of joining the resistors together. One in series and another is resistances in parallel. Now let's see resistances in series. When two resistances are joined end to end consecutively, they are said to be connected in series. This R1 and R2 are joined in series between points A and B. Now this is a circuit showing how resistances R1, R2 and R3 are joined in series in a circuit. When resistances are joined like this, the combined resistance R is equal to the sum of their individual resistances R1, R2 and R3. Thus, the combined resistance is greater than any individual resistance. Now, we will see what happens to the voltage and the current. In series combination of resistors, the current is same in every part of the circuit. Now we will see about the potential difference. The potential difference V is equal to the sum of the potential differences V1, V2, V3, that is the total potential difference across a combination of resistors in series is equal to the sum of potential difference across the individual resistors. So for series combination, total resistance R is equal to R1 plus R2 plus R3. The potential difference V is V1 plus V2 plus V3 and current is same in every part of the circuit. Now we will see the resistances in parallel. Here resistance R1 and R2 is connected in parallel between the points P and Q. This is a typical circuit showing resistances R1, R2 and R3 connected in parallel between points X and Y of this circuit. The reciprocal of the resultant resistance of resistors connected in parallel is equal to the sum of the reciprocals of all individual resistances, that is 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 and so on. Thus, when a number of resistances are connected in parallel, then their combined resistance is less than the smallest individual resistance connected in the circuit. Now we will see about the voltage and the current. In parallel combination of resistors, the potential difference across each is same, which is equal to the voltage of the battery. When a number of resistances are connected in parallel, then the sum of currents flowing through all the resistances is equal to the total current flowing in the circuit. Now we will summarize this. Now let's tabulate it so that we can understand it easily. Resistances in series. When the resistance are connected in series, combined resistance R is equal to R1 plus R2 plus R3, so on. When the resistances are in parallel, the reciprocal of the combined resistances R is 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 and so on. This combined resistance R is greater than the individual resistance, that is R is greater than R1 greater than R2, this R is greater than R3, and so on. In parallel resistances, this combined resistance R is less than the individual resistances. So R is less than R1, R is less than R2, R is less than R3, and so on. When the resistances are connected in series, current is same in all parts of the circuit. When the resistances are in parallel, total current I is equal to I1 plus I2 plus I3, and so on. When the resistances are in series, the total voltage V is equal to V1 plus V2 plus V3, and so on. When the resistances are in parallel, V is same in the circuit. Resistance in series is used to decrease the current in the circuit, whereas resistances in parallel are used to increase the current in the circuit. Now we will see where to use the series and where to use the parallel resistances. This depends upon the intended use of the circuit. For example, a large number of bulbs are connected in series for decoration so that they can be controlled by just one switch. But if one bulb gets fused, then the circuit breaks and all the bulbs are turned off. So to repair this, electrician has to spend a lot of time to find the fused bulb and replace it. So let's see how series combination works. It can be controlled by a single switch, but if one appliance stops working, the circuit breaks and the whole system stops working. Power supply voltage V is generally 220 volt. In series, V is equal to V1 plus V2 plus V3, that is V is shared among all the appliances and they get low voltage. If they get less voltage, they do not work properly. In series, resistance R is equal to R1 plus R2 plus R3. That is, resistance is high, so current is low. This low current is flowing through the circuit of the appliances having different power ratings, so they cannot draw sufficient current for their working. Now let's see how parallel combination works. In parallel circuit, each electrical appliance has its own switch. For example, we have separate switch for every tube in our house. In parallel circuit, even if one appliance stop working, rest of the appliances work. If one bulb is fused in our house, rest of the bulbs are working. In parallel, 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. That is, resistance is low, due to which current is high. So every appliance can draw the required amount of current for their proper working. These are the reasons why parallel circuits are used in domestic wiring.